In this thought-provoking video, we explore the intriguing question: if scientists were wrong about COVID, could they be wrong about climate too? As we delve into the nature of scientific inquiry, we'll examine how the pandemic highlighted both the strengths and vulnerabilities of scientific understanding. By learning from the challenges faced during the COVID-19 response, we pave the way for a deeper discussion on the complexities of climate change. Join us as we critically analyze the role of data, trust, and communication in science, and consider how these factors shape our understanding of an ever-evolving world. 1. The nature of scientific inquiry. Science is a journey, not a destination. It's a process that involves making observations, forming hypotheses, and testing them with experiments or data. Scientists are human, and like all humans, they can make mistakes. The COVID-19 pandemic is a prime example of how scientific understanding evolves. Initially, there were uncertainties about transmission, treatment, and prevention. As new evidence emerged, guidelines and recommendations changed. This adaptability is not a flaw, it's a feature of scientific inquiry. It's essential to understand that science is built on the foundation of questioning and refining. The same principles apply to climate science, where research is ongoing, and new data can lead to revised understandings. 2. Learning from COVID-19 missteps. During the COVID-19 pandemic, the world witnessed rapid shifts in scientific guidance. Masks were initially deemed unnecessary for the general public, only for this advice to be reversed later. This was not due to incompetence but rather the evolving understanding of the virus. Similarly, climate science has experienced its share of revisions. For example, early climate models underestimated the speed of Arctic ice melt. By acknowledging past mistakes, scientists can refine their models and predictions. This iterative process is crucial for improving accuracy and ensuring public trust. 3. Climate change. A complex puzzle. Climate change is like a giant jigsaw puzzle with many interconnected pieces. Factors such as greenhouse gas emissions, deforestation, and ocean currents all play a role. Scientists have been studying these elements for decades, and while much is known, there are still pieces missing. For instance, cloud cover and its impact on climate is an area of ongoing research. Just as with COVID-19, new discoveries can lead to shifts in understanding. However, the overwhelming consensus remains: human activities are driving climate change. 4. Trust in science. A double-edged sword. Trust in science can be both empowering and challenging. On one hand, it allows society to make informed decisions based on expert advice. On the other, it requires faith in the scientific process, even when recommendations change. The COVID-19 pandemic tested this trust, as people grappled with changing guidelines. Climate science faces a similar challenge, as skeptics question the validity of models and predictions. It's vital to acknowledge the provisional nature of scientific findings while recognizing their broader truths. 5. The role of data in shaping opinion. Data is the backbone of scientific understanding. During the COVID-19 pandemic, real-time data collection was crucial for tracking infection rates and vaccine efficacy. This data-driven approach is equally important in climate science. Satellite imagery, temperature records, and ice core samples all contribute to a comprehensive picture of our planet's health. However, interpreting this data can be complex, leading to differing opinions. It's essential for scientists to communicate findings clearly and for the public to remain open-minded. 6. Comparing COVID-19 and climate change. While COVID-19 and climate change are vastly different challenges, they share some commonalities. Both involve global impacts, require international cooperation, and demand urgent action. The pandemic highlighted the importance of listening to scientists and adapting to new information. Similarly, addressing climate change requires flexibility and responsiveness. One key difference is the timeline. While COVID-19 demanded immediate action, climate change is a long-term challenge. However, the urgency is no less critical. 7. The importance of communication. Effective communication is crucial for bridging the gap between science and the public. During the COVID-19 pandemic, mixed messages and misinformation created confusion. Clear, consistent communication is vital for building trust and understanding. In the realm of climate science, this means explaining complex concepts in accessible terms. Metaphors, such as comparing the Earth to a greenhouse, can help convey ideas. By fostering an open dialogue, scientists can engage the public and encourage informed decision-making. 8. A future of continuous learning. The world is constantly changing, and so is our understanding of it. The COVID-19 pandemic taught us the value of adaptability and resilience. These lessons are equally applicable to climate change. As new data emerges, scientists will continue to refine their models and predictions. This ongoing process of learning and adaptation is what makes science so powerful. By embracing change and remaining open to new ideas, society can navigate the challenges ahead with confidence and hope.